Hello, my name is Cesar Meza, and I'm a master's student in the Department of Mathematics at San Francisco State University. My advisor is Dr. Federico Ardila. I'm grateful to the ARCS Foundation for this opportunity, and I look forward to pursuing a PhD in the fall. My research is in an area of mathematics called polyhedral combinatorics, and in particular, I study objects called polyhedra. First, let's define a polygon. A polygon is a two-dimensional object with straight sides and no indents. The green square is an example of a polygon, but the red object to the right is not because of the indent at the top. We can take this definition into the third dimension to define a polyhedron. A polyhedron is a three-dimensional object with straight sides and no indents. The green cube is a polyhedron, but the red object to the right is not because of the indent at the top. Now let's look at some of the components of a polyhedron. Here we have a tetrahedron. First, we have vertices, which are the corners of the polyhedron. In this case, there are 4. We also have edges, which are the segments connecting the vertices. In this case, there are 6. There's 3 vertical edges and 3 at the base. And finally, we have faces, which are the flat sides of the polyhedron. In this case, there are 4. 2 at the front, 1 at the base, and 1 in the back. Here are the 4 remaining Platonic solids. I've included the vertices, edges, and faces for each of them. Remarkably, for any 3-dimensional polyhedron, if you take the number of its vertices, subtract the number of its edges, and add the number of its faces, that number will always equal 2. This is a fundamental truth of 3-dimensional polyhedra. In fact, this relationship continues in higher dimensions. And in particular, my research investigates those relationships. Finally, I want to thank my advisor, Dr. Federico Ardila, and the ARCS Foundation. You make pursuing a PhD a reality for me. Thank you.